Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. Today, we're talking about Lesson 27 in our Blue Book. And Lesson 27 is all about the area of triangles. And we're going to learn how to recognize and find the area of 3 different types of triangles. Now, the one that is the easiest is a triangle that is a right triangle, because we're always going to be looking for the base and the height. And the base and the height will always be perpendicular or right angles to each other. So here you see the right angle in here. And so we're going to call one side the base, and the one that's perpendicular to it we will call the height. And the area of a triangle is 1/2 base times height. So all I have to do is find these two, base and height, and multiply them together and then divide by 2, and I have the area of the triangle. Now sometimes we're going to see a triangle that does not have, it's not a right triangle, but once we find the base, we can draw a perpendicular line to the base up through the apex or the vertex of the triangle there. So when we do that, if we can find that length there, that is then the height, and we will have the base times the height divided by 2, or 1/2 base times height. So it's no biggie if you don't have a right triangle. You're just going to make a perpendicular line to the base through the other angle there. And then sometimes we have obtuse triangles, okay? And an obtuse angle is going to make the, you don't have a right angle, but what we can do then is extend our base and then drop a vertical down, so that over here is our right angle, and our height is this vertical distance here that is perpendicular to the base. When we do a base extension, we do not count this dotted part in the base. That's why I have it dotted instead of solid. Our base is only the solid part over here times the height that comes down. This little extension just tells us where to stop this height from going. Okay, so we're going to talk about each one of those. And we call the height also the altitude, and our altitude always runs perpendicular to our base. Now, in every triangle, we could have any one of our sides be our base if we can find a perpendicular to it that's going to be our height. And a lot of times it will depend on which measurements we're given in a problem as to which base we're going to choose and which height we're going to choose. Okay, so basically this triangle right here, I have it oriented here, but I could also turn it around and use this as the base, and then I would do the problem like this one, right? I could turn it around and then I could drop a base. It all depends on what is given to us in the problem as the heights and the measures that we already have. So here is our written formula for the area of a triangle. Area of a triangle is 1/2 the base times the height. So what we have to do is make sure the base and the height are always perpendicular or right angles to each other. So now we have an example, and this one we only have one example. This is a very quick lesson. So we have this one, which has got a base of 6 and a height of 4, and it is a right triangle, so we're right ready to do that area, right? So 1/2 base times height is the area. And so we would have 1/2, and the base in this one is 6, and the height is 4, and 1/2 of 6 is 3, and 3 times 4 is 12. So the area of the triangle is 12. And we would, since that's area, we would put it in square units. So we'll just say 12 square units there. So we always put our units of measure. So now that one was 6 and 4, but it was a right triangle. Look at this one. This one has got a base, but it doesn't have a right angle. So what we did was drop a vertical to the base and made it at right angles with the base. So now this is my base, and this vertical drop here is my height. And the base is 6 and the height is 4. So guess what? 1/2 base times height is the area. And again, we're going to have 1/2 times 6 is 3 times 4 is 12. So we're going to get 12 square units, just like we did for the last one, right? And then we have one more triangle, and this one is obtuse, isn't it? Okay, an obtuse angle is bigger than 90 degrees, isn't it? So here I'm going to have my base is 6, and my height is this vertical drop down that is perpendicular to the base. Now my base here, my 6, is only this part that is solid, not this extension. So again, 1/2 base of 6 and height of 4, and 1/2 of 6 is 3 times 4 is 12 square units again. So we did 3 different triangles that had the same area because they had the same base and height, but they looked very different. One was right, one was acute, in other words, all of the angles were less than 90 degrees, and then this one was obtuse, and we did it a little differently each way, but we got the same area each time. Okay, we have our practice problems on the board. So as soon as you copy down your 3 practice problems, you're going to need to go and do those on your own. So pause your video. Okay, hopefully you have your answers. So this one is a little bit misleading because notice it does have a right triangle. So even though it looks like the base should be 5 because it's lying on that side, we're going to turn it around. Remember, our base and our height are always perpendicular to each other. That means they're at right angles. They should have this little box in between them, right? So it doesn't matter whether we choose 4 for our base and 3 for our height, or whether we choose 3 for our base and 4 for our height. We're going to get the same area because area is 1/2 base times height. So let's just say that our base is 4. Okay, so our base is 4 and our height is 3. So we multiply, and 1/2 times 4 is 2, and then 2 times 3 is 6. And notice I would get the same thing if I just said, let's do these 2 first and get 12. 1/2 of 12 is 6. They said this was in square feet. The units were in feet, so this would be square feet. Okay, so that's the first one. Now let's look at this one. This one is a very interesting one because this one is actually an isosceles triangle. And you'll learn more about triangles as you go on. But notice how the vertical line comes straight down and there's 4 on each side of that vertical height. That tells me that it is isosceles, which means that these sides are the same. But we're not really studying that right now, so let's kind of leave that for later. But we have a base and a height that are perpendicular to each other, notated by the little box. So our base is 8 and our height is 6. And we're going to put 1/2 in front of that because the formula is 1/2 base times height. So that's going to be 1/2 of 48, which is 24. Okay, or we could have said 1/2 of 8 is 4, and then 4 times 6 is 24. So the answer there is 24 square feet, but I don't have room to write square feet on that one. So I'll let you do that on your paper. Okay, and the last one down here is obtuse. Now notice we had one that was a right triangle. That's like the first one in the example. This one is one that we had to make a right drop here. So we had to come on perpendicular to the base. We had to draw a line up to the triangle and find out that's triangle's apex or other vertex and find the height. Now this one is obtuse. You see that angle that is bigger than 90. Okay, so now we're going to find this is our base. We extended the base, but we do not count that in the base. So the base is just the 10, and then this height, which is perpendicular to the base, is 8. So we're going to find 1/2. The base is 10. This drop height here is 8. So 1/2 of 80 is 40, or 1/2 of 10 is 5, and 5 times 8 is 40 square feet. And that is your practice for this lesson. That wasn't much of a lesson. That's a lot of fun, but not too much to learn in one lesson. So, I hope you have fun doing your homework. And this is Mrs. A, and may God bless your day.